All right, how you guys doing today out in Geometry Land? This is Mr. Muscarella and
Miss Wiggins, guest speaker.
Coming at you to talk a little bit about surface area and volume ratios. So check this out. Some information about the surface area and volume of two similar solids has been given. Find the missing value.
Mr. Muscarella, I bet that word similar is important in this problem.
Oh my gosh, you are so right, Miss Wiggins. So two similar solids, if two similar solids are given to you, what does that tell you about, what does that mean, two similar solids?
Well, let me think. When I think of similarity, there's one magic word that comes to mind, and that is proportion. So does that mean those solids are in proportion?
Why, yes, Miss Wiggins, they are in proportion. So what we're going to do is we're going to take the surface area of the first figure, which is just 147. And we're going to leave off the units. Well, if we put them in, you'll see that they'll end up canceling out. And then the second solid, you have 108 square meters, and those will cancel out. Now, why are we doing this?
I think we want to find what the proportion is.
Well, yeah, so what we're going to do is just reduce that, and 3 goes into both of these, so when you reduce that, you end up with 49 over 36. But we're not done there.
We're not.
We've got to do one other thing to come up with a scale factor. Do you know what that thing is?
Oh, I think I'm remembering. 'Cause since the scale factor is the ratio of the lengths, the two-dimensional lengths of a figure, we have the area ratio, so we need to, area is all about being squared, right?
Yes, so that's a 2D kind of representation, whereas side lengths is just one dimension.
That's what I meant to say.
Okay, that's awesome. So how do we figure out what the one-dimensional piece is for the side lengths?
I think we square root. Am I right?
Yep. So we're going to square root each one of these, and then we end up with 7 over 6. So now what do we do with that 7 over 6?
So that's the scale factor, right? That's the relationship of, that's the proportion of the big figure sides to the little figure. So if we want to now solve for the unknown volume, we have to do something to that scale factor.
All right, well, volume is unlike area, because area is 2 dimensions, but volume is 3 dimensions. So when we work with area, we always would square our scale factor.
Raise it to the second power.
Raise it to the second power. So if we're going to deal with volume, since that's 3 dimensions.
I know.
What do you think we're going to raise it to?
The third power.
All right, so we're going to cube each one of these. Now when we cube 7, do you know what that value is off the top of your head?
Of course I do.
What is it?
343, Mr. Muscarella.
Oh, you rock. So that's 343. What about 6 cubed?
216. You made me memorize these.
Yes, very good. So we got 343 over 216. Once we have that, now we're going to go back to our problem and take a look at the volumes that were given. So now we're going to set up this ratio of 343 over 216. Now 343 deals with the first solid, and 216 deals with the second solid. We're going to set that ratio equal to 8918 over, well, I don't know what the volume of the second figure is, so we'll just use x.
Good. Uh-oh, I think I need a calculator for this one.
Yes. So what we're going to do is go ahead and multiply. We're going to cross multiply and then divide. So we'll have 343x equals 8,918 times 216. Oh, that's a big number.
Yes, but my calculator got it.
And what is it?
We've got 1,926,288.
Oh my gosh, that's huge. But that's okay. That's why we use a calculator. And then what do we do next after this?
Well, divide by 343 to get x alone, of course.
And that, what did your calculator give you for that?
5,616. And what did we just find?
So what, like 5,616, what is that?
Well, let's see. We're solving for the volume, which is given in cubic units, and these were meters. So I think that's the volume of our solid number 2, 5,616 meters cubed.
All right, excellent. Now don't forget to put your units on there. No units, no point for you. All right, so that's how you do this problem. So let's just kind of recap. First, find the scale factor. Then use that scale factor to go ahead and cube to come up with the ratio for the volumes. Once we have the ratio of the volumes, then all we do is set up a proportion, cross multiply, and divide.
Awesome.
All right, go ahead and try example number 22 on your own, and then come on back and see how you did. Thanks, Miss Wiggins.
You're welcome. Thank you.
All right, so hopefully you found the answer for this one. We got our scale factor of 1 over 4, but then when we cube it, because we're dealing with volume, we end up with 1 over 64. Setting up that proportion with 136 over x, the ratio of the corresponding values, you get a value of 8,704 cubic feet. All right, that's it for this video. Thanks for watching, boys and girls, and I'll catch you later. Peace out.